In the 18th lecture of probability theory, we continued and concluded the chapter related to the reliability theory. We first analyzed the case of a system where n different distinct units are arranged in parallel. As for units in series, we have made use of indicators x and also y in order to compute the reliability of such system. We have then discussed how to find out the reliability of a system where units are arranged not completely in series nor in parallel, like the one shown in here. We first consider example 1, where the system can be broken in two parts, where units are first only in series, like 1, 2, and 3, 4, and then only in parallel. We have also noticed, however, that for other systems, like the bridge system, such decompositions cannot work. Hence, we define what are minimal path sets and minimal cut sets of a system. These sets are useful to calculate the reliability of the system, as they let us define an equivalent system that has the same reliability of the original one. In particular, when considering minimal path sets, the original system is equivalent to a parallel arrangement of the minimal path sets, with the members of each minimal path sets arranged in series. On the other hand, when considering minimal cut sets, the original system is equivalent to a system represented by series arrangement of the minimal cut sets, where the members of each minimal cut set is arranged in parallel.